Hello everyone. Okay, this is a short video on how to derive the import demand function and the export supply function from simple supply and demand equations under the assumptions of a small country. Remember, the small country assumption is needed because whatever happens in this country could possibly affect the world price if the country was large. So in this first problem, we assume the country is small, therefore we can take the world price to be fixed. Okay, so let's begin. Let's see if I can get my image off of here, and maybe you can see that. Do you see that? I hope so. Alright, so you have in front of you a simple supply and demand equation like you've seen a million times. We're going to find the equilibrium quantity and the equilibrium price. So it turns out that the equilibrium price, I think, works out to be 200, and the equilibrium quantity would simply be the quantity demanded or the quantity supplied at 200. So working from the supply equation, I get 500. So this number down here is 500. So this is the situation in this small country if they don't engage in trade. Now, if we allow them to have trade, we need some assumption about what the world trade price is. So let's start with an assumption that the world price is below their equilibrium price, maybe at 150. So that'd be here. So if they open the borders to trade, some people are going to be better off and some will be worse off. The producers will be a little worse off because their price is now lower. They used to get $200 per unit. Now they only get 150, and they will produce a little bit less, which we'll calculate in a minute. That's the quantity supplied. At the same time, consumers will be better off because they used to pay $200 a unit, and now they only have to pay 150. So their quantity demanded will be slightly higher. I get the quantity demanded as 1,000, so this number right here is 1,000. I get the quantity supplied is only 250. So this means that they're only going to produce 250 units, but they're going to consume 1,000 units. Without trade there would be a shortage, but with trade they will just import that. So this will be their import, and I hope you can see that they will import 750 units. Can you see that? Now we can work all that out algebraically by remembering that the import demand function, I think in class I called it excess demand. So excess demand, or you can call it the import demand function, is equal to the quantity demanded minus the quantity supplied. So by substitution, that's just 2,500 minus 10p minus 5p minus 500. Remember your parentheses. Then gathering up all those terms, I get 3,000 minus 15p. So that's my import demand function. Now let's check our work and make sure it's right. So it should be that when the price is 200, it should be that they don't want to import any, because remember, when the price is 200, they produce 500 at home and they consume 500 at home, so there would be no demand for the foreign good. So let's see if that's right. If I put a price of 200 into my import demand function, that is, if I put that price right there into P, so 200 times 15 is 3,000, and 3,000 minus 3,000 of course is 0, so that's right. When the price is 200, the import demand will be 0. Now when the price is 150, it should be that we want to import 750. So let's see if that's right. So when the price is it'd be 15 times 150 is 2,250, and I'm going to subtract that from 3,000, and I do get 750. So this is correct. So this is the import demand function right here that we have derived from the regular demand equation, which is over here in the regular supply equation, and the given world price of 150 units. Remember? 150 units. Alright, now how does it look visually? Well, visually, let's draw it down here. And I'm going to make the same little mistake that I made in class and draw it down here. So this is our quantity demanded of the imported product, and this is the price we're going to pay. But notice that it makes a lot more sense to move the price axis. So I'm going to erase this, going to move that thing, and I'm going to set it over here so that it makes more sense in terms of the scale of the graph that we have above. So this is the price axis. And according to the work we just did, it should be that when the price is 200, the quantity demanded should be 0. Remember, we worked that out. And when the price was 150, it should be that the quantity demanded is 750. It's out here somewhere. And so this is our, that should be a straight line, this is our import demand function. Now, what about the export supply function? Well, it's easy to see visually if you well, I don't know if you're a visual learner, it is. If you take this demand curve and you just extend it back this way, right, the very same function, it turns out that this is the export supply curve. The easiest way to see it is these are positive numbers over here, so this is the quantity demanded, and this would be negative quantity demanded. Negative quantity demanded, or another way of thinking of it is we're going to consume negative units, which is kind of a bizarre way of saying we're going to sell units. So that's the supply equation, and you can get its equation very simply from the import demand equation simply by changing the signs. So the export supply equation will simply be minus 3,000 plus 15p. Now I know it's a lot for you to just assume, well, Dr. Height said that's what it'll be, so I'm just going to memorize that. So I'm going to show you how to derive it. The way you derive it is the export supply equation has a formula. It's simply the quantity supplied minus the quantity demanded. Notice that's just the opposite of what the import demand function was. You remember, quantity demanded minus quantity supplied. Now we have quantity supplied minus quantity demanded, and by substitution that's 5p minus 500 minus 2500 minus 10p, and when you work that out, it will work out to be exactly minus 3,000 plus 15p. Okay? Now let's try one in the graph. So my graph has gotten kind of crowded, but we had an original autarky price of 200. So let's say that the world price wasn't 150, that instead maybe the world price was 225. So that'd be somewhere like this, 225. So by assumption, let the world price be 225, and it should be that this is the quantity demanded, right? A little bit less than what they would do before, and this is the quantity supplied over here. So in this case, the producers are better off and the consumers are worse off. And let's figure out what those numbers are. It turns out that at 225, the quantity demanded works out to be 250. So this number right here is 250. And the quantity supplied at 225 works out to be 625. So it should be that we would export the difference, 625 minus 225, that's 500, isn't it? Oh, I'm sorry. I got 375. 375. Let me make sure I didn't screw up. 625 minus 250. Yeah, 375. It should be. Okay, so that's how you do it from the original supply and demand equations. Now let's see if that's what our excess supply equation gives us. The excess supply equation says it should be 15 times 225, and then we're going to we're going to subtract from that 3,000, and I get 375. That's exactly right. So what we have now is we've derived the excess supply equation and the excess demand equation, or to use maybe language that would be better for you, I should probably use this language. We've derived the import demand curve and the export supply curve from the original supply and demand equations and all the different possible world prices. Okay, so let's see. Hey, what happened to my image? Oh, there it is. So I don't know how long that's been a blue screen, but I hope you have everything there that you need. And here's me again. So let me know in class if this isn't helpful. Okay, good luck.